invitation. Dear colleagues, nice to meet you. And I would like to tell a few words about hydrological measurements. Thank you, Pavel, for the introduction to meteorological measurements. And first of all, I would like to say that hydrological measurements is the large branch of practice in hydrology. And I will tell only a few words to introduce in such branch. The next, please. Hydrology is the science about water, and hydrological measurements are a very strong basis for hydrology. And first of all, hydrology and meteorology, I'd like to say that hydrology and meteorology have a symbiotic relationship, very strong, because the hydrology rivers are the produce of climate, as we know, it is said by Voyekov. And the next, water bodies face very strong stress, especially in last years. And so why hydrological measurements? The main purposes of hydrological measurements is planning, making the construction, buildings, and the second is design. It helps us to ask some questions. For example, how high should the bridge be to be safe? And for example, where do we need a pumping station or irrigation? And management goals, for example, when to start irrigation, when to start pumping, and a wide range of different kind of research on processes, interactions, and changes in hydrological sphere. And requirements for these purposes are following. For planning, it's a time series, most of all large-scale time series. Design. For design, we need small-scale time series, additionally to large-scale. For management, additionally, we need real-time data and forecast. For research, we have to use high-quality data. And according to World Meteorological Organization, hydrosphere measurements are divided into groundwater, sediment transport and deposition, stream flow, different kind of stream flow measurements, and oceanological measurements, waves, tides, and currents. The next, please. The next slide, please. And developing data divides into three major parts. It's data processing, raw data, first of all. It is data collection, data storage and retrieval, and the last, dissemination of data. Data analysis, it's also a wide range of different theories and practice. It's a correlation theory, assessment of errors and uncertainties, statistical analysis, and etc. And the second is the last is data implementation. It's a water resource assessment, hydrological prediction and forecasting, management and warning. The next, please. And Gaussian network for hydrological measurements should be projected based on several principles. The main principles are divided into spatial distribution and density. This is made for a reflection of different natural conditions and human-made conditions. Hydrological network should be representative to describe distinctive and special water characteristics, and accurate to be adequate for scientific and economic needs. And also, hydrological network should be based on water use plans to have information, to provide information for developing territories and developing cities and economical activities. And because of limited funding, especially in developing countries, hydrological network cannot be very dense, and hydrological stations should be situated in the most distinctive areas. For example, near the borders, near cities, it is necessary to have hydrological gauging in the estuaries and undeveloped areas. The next, please. First of all, hydrological measurements. When we speak about hydrological measurements, we tell about stream flow gauging. Stream flow gauging programs are very different between countries, between territories, and these programs can consist of 2 or 3 components. For example, on small hydrological stations in Russia, up to hundreds of characteristics. For example, in Latvia. These characteristics are water level, water discharge, temperature, sediment transport characteristics, ice regime, a lot of points of ice regime, water quality, hydromorphological monitoring, and hydrological situation. The next, please. Stream flow gauging, the most widespread hydrological measurements are water level measurements. Water level gauges can be with different constructions, and first of all, it can be manual or automatic. The most widespread manual water gauge types are pilot gauge and staff gauge. Pilot gauge should be projected on the banks, on steep slopes, on rivers with high water level fluctuations. If water level fluctuation is not very high, it can be rack-based gauge. Semi-automatic type of water level gauge is limnographs. Water gauge is equipped with some kind of recorders. The very old type of recorder is limnograph or mareograph. In Russia, it's called Valdai type. It is a water level tower equipped with float, rope, and wheel with recording paper to have a time series of water level fluctuation. The next, please. Another type of water level gauge is automatic water level gauge, and it is a modern type of water level measurement type. The main principles of these kind of water level measurements are optical, pressure fixation, and other types. The next, please, with automatic water level gauge types. Thank you. Automatic water level gauges are most widespread in the whole world. And another significant type of water level water measurement is discharge measurements. Discharge measurements historically are made with current meters. Could you please, the next slide? With current meters of different types, and it is most widespread in the world type of water velocity measurement. This kind of equipment is used to measure water speed in one point of the cross section, and then water discharge is calculated using mean velocity multiplied with cross section area. In Russia, the main type of current meter is called ESP1. It's a current meter, and in the world, the modern type of water velocity measurements are measurement equipment are electromagnetic or some kind of this, and semi-automatic. On the picture, you can see that type of water velocity measurement with the boat on the large river. The next, please. And a few years ago, not many years ago, it could be possible to measure whole current velocity and discharge, total discharge on rivers using acoustic Doppler technology. And the most widespread equipment is acoustic Doppler current profiler, which can measure velocity, magnitude, and direction, and its distribution down and through the cross section. It can measure backscatter intensity, total discharge, partial discharge, and it has three special scales. On whole transect, ensemble, the vertical beam, and one small cell. And it brought a lot of information about current distribution, not only total discharge, but magnitude and direction of velocity on different parts of cross section. The next, please. Could you please, the next slide, please. And I told about very basic measurements in hydrology, and special and very specific measurements are in winter period, especially in Russia and cold region, such as Finland. And winter measurements bring a lot of difficulties. For example, it's solid precipitation, which accumulate on the watershed catchment and do not go through the river and do not become a river flow immediately. It is snow cover and ice cover on rivers and lakes, which strongly affect the dynamical structure of the flow. Main elements of ice regime, which are observed and measured, are ice cover ratio, thickness of ice, etc. These measurements are vital, are essential for ice predictions, because in many regions in Russia, not very many roads equipped with bridges, and many rivers are crossed by car only on ice, on ice cover, and it's necessary to know physical characteristics of the ice to provide transportation. And snow surveys are being made to have information about water balance, about amount of water which will come into rivers in spring. And it's also very difficult and not so widespread in Russia. Now, for example, it's not enough to have information about snow cover distribution. So snow cover surveys are basis for remote sensing data and remote sensing using for snow cover and snow depth and snow water equivalent assessment. The next, please. And hydrological measurements are the basis of for the different kinds of modeling. For example, for hydrological modeling and for hydraulic modeling. Different kind of measurements are used to calibrate hydrological models, for example, river discharge, and also meteorological data, watershed data. As a result, hydrological models can provide simulated time series and water use scenarios. Some elements of water balance, and to investigate hydrological consequences of the climate change. Hydrological models are the most widespread instrument to assess climatic impact in the future on hydrological cycle. Hydraulic models require a lot of data of hydrological measurements, for example, discharge, water level data and time series, morphometric data, and also meteorological characteristics as an option. As a result, hydraulic models provide water level, water velocity, discharge distribution, flood wave simulation, erosion, and also different scenarios of water use. The next, please. And there are a lot of interesting information all over the world, some innovative measuring methods. For example, very interesting method, large-scale particle image velocimetry. It has a lot of advantages against traditional methods of velocity measurements. It does not require intrusion into measurement technique. It has instant and average two-dimensional velocity fields, but only on water surface. And so on, some interesting features. For example, crowdsourced analysis. And on the pictures, you can see some equipment for this kind of measuring method, especially distributed camera to fix to observe surface velocity, and laser scanned elevation model for the riverbed, and using general equation for discharge, mean velocity multiplied with area of cross section, we can calculate the discharge and investigate special distribution of flow velocity. And there is the smartphone application. It is already exist in Apple Store and Google Play, and every person can try to measure velocities in the streams. And these kinds of innovations can be applied with all over the world. The next slide, please. For example, in 2018, it was a large paper investigated the citizen science in hydrology. Total, it was about 70 researchers made with citizen science. It is crowdsourced data collection. People involved in this technique, in this procedure, can obtain water level, water quality, also precipitation, and some observations on water bodies. And I see this technology is very nice and can be global, and it can provide a lot of information which cannot provide the traditional type of hydrological measurements. Thank you for your attention. I hope hydrological measurements and obtaining hydrological data will grow, will increase, and in a few years we will have a lot of information to solve a lot of problems. Thank you so much, and sorry again for the problem with the connection.
Thank you, Pavel, for very interesting lecture, and also Pavel Tersky and Pavel Konstantinov. Dear colleagues, if you do have questions, please address to our presenters.
So, Alexander, since we have as I can see, some questions, so I have the maybe small question to Pavel Tersky. So, how do you think, Pavel, what will be the most challenging problem in the measuring of hydrological properties, maybe for the nearest years. So what now is can be measured more intensive according to the new some approaches. So how do you think?
Thank you, Pavel, for your question. I think it has this problem has some stages. The global stage and the organizing stage is the planning and the interpretation of hydrological measurements because of rapidly developing world and developing river valleys. It should be much more dense network of measurements, and another more modern protocol of this measurements analysis all over the world and in Russia, and such as globalization of the measurement data, because in Russia we have problems with data obtaining. It is not free of charge, and I see it is necessary to have large amounts of information because of developing of technologies of big data, and these technologies and this approach to data analysis requires a lot of data. Another stage, maybe small scale stage, is the modernization of network. I think in developed countries, this problem is not so urgent, but in Russia and in developing countries, this problem is very strong because of major part of hydrological stations are equipped with old and not so representative equipment, and people who work on this network cannot use modern equipment. For example, acoustic Doppler technology. In Russia, this technology is not widespread, and is used on only a few stations, not in every region.